I would like to talk about the 3D print through the next few slides. The following slide is a view of the American lunar probe Apollo 11 being welcomed by the citizens of Houston after it returned to Earth in 1969. However, NASA of the United States invested a huge cost equivalent to about $200 billion in today's value for the Apollo project. It has become difficult to continue space exploration at such a high cost. As the cost of space exploration increases, various attempts have been made in the private sector to reduce the cost of space exploration. As you can see, in the case of the Saturn V rocket used between 1967 and 1973, it cost $23,750 per kilogram of rocket weight to go to LEO, the low Earth orbit, whereas the Falcon Heavy was developed in 2018 by SpaceX was available at the $1,200 only. As a result, technological advances are creating tremendous competitiveness in space exploration. Elon Musk's unlimited efforts for space exploration made it possible to have a competitive edge in space exploration that NASA could not do. Such efforts did not come easily. Let's check out Elon Musk's constant innovation in space exploration technology through the following video clip.
Most space organizations, government or commercial, have set their sights too low. They've really built relatively small rockets. And Falcon Heavy is the first time that there's something that's arguably even in the super heavy class, or somewhere between heavy and super heavy. 5 million pounds of thrust is really crazy amount of power. More than twice as much payload as any other rocket in the world. It can launch things direct to Pluto, no stop needed.
Hotels in the area are completely sold out.
Yeah.
Parking lots are packed.
It's like the first time something exciting has happened in rocket launch in a very long time.
Falcon Heavy is configured for flight.
T-minus 15, standby for terminal count.
SpaceX Falcon Heavy, go for launch.
10, 9,
All systems go.
8,
3. Side booster ignition.
6, 5, 4, 3, 2, 1.
Building on the history of Saturn V Apollo, You've got to be kidding me! What?
Elon Musk has been able to make our imaginations possible through endless challenges with some failures step by step for space exploration. Elon Musk's final purpose in exploring space is to eventually send humans to Mars and ensure that they can survive sustainably. What makes these things possible is to build the necessary buildings with a 3D print. Even if humanity could go to the moon or another planet, it would be meaningless if sustainable living conditions were not possible. This slide shows how to make residential facilities for lunar exploration using 3D print. It is 3D print that makes these obstacles and challenges possible. The 3D print will make it possible to build structures where human beings can live by using the ingredients of the soil and bedrock on each planet as anchor.
Planet Earth is protected by the atmosphere, the layer of air and gas that surrounds it. The atmosphere shields the Earth from solar radiation, keeps the temperature balanced, and protects us from meteoroids. On the Moon's south pole, you can see almost perpetual sunlight on the horizon. This is the site of our lunar base. Conditions on the Moon are very different from those on Earth. Because the Moon has no atmosphere, there is no protection from solar radiation. There are extreme temperature fluctuations. And there is no protection from gamma radiation, and no protection from meteoroids. The lunar lander has detached from the rocket launch and is on a course to Shackleton's crater, the Moon's south pole. Inside the lander is a cylinder which contains an inflatable dome and 2 robot 3D printers. After the cylinder containing the habitation capsule has been unloaded, a dome is inflated from one end. This provides the support structure for construction, a little like scaffolding is used to build on Earth. The lunar habitation is built by a robot-operated 3D printer. At one end, it has a scoop to collect the regolith. In the centre are the containers for the printing material. At the other end, there is a robotic arm with a printing head. The robot collects regolith from the Moon's surface. Layers of this moon dust are built up over the dome to create the protective shell. This process takes about 3 Earth months. The shell is made up of a hollow, closed cellular structure. Under a microscope, it would look very similar to the close-up of a bird's bone. Like a bone, it is light and incredibly strong at the same time. When the lunar base is complete, it can house 4 people. Inside the dome, they are protected from meteorites, gamma radiation, and high temperature fluctuations. The original capsule functions as an airlock and technical support module. The skylights draw daylight into the living and workspaces, which are sheltered within a pressurized enclosure. This method is a pioneering advance in space-age construction. At Foster & Partners, We're used to designing for some of the world's most extreme climates. We often use materials found locally to create sustainable buildings on Earth. While the Moon is an exciting new territory for architecture, the value of this logic endures.
Finally, I would like to talk about the AI robot Jill Watson, an assistant at the Georgia Tech. Professor Ashok Goel of the Department of Computer Engineering entered the answer against about 40,000 questions to the AI assistant in order to increase the low repeat registration rate of his online classes. As a result, the AI assistant was selected as the best assistant by responding to students' questions efficiently. The mega trend of the second technology of the fourth industrial revolution is digital. As you can see in this slide, Masayoshi Son, chairman of the SoftBank Japan, is famous for making a lot of investment in various fields with a common vision centered on AI. He nominated his successor, Nikeshi Arora, for retirement, but soon overturned it by paying him $328 billion. The reason for this overturn is the singularity predicted by Ray Kurzweil. Ray Kurzweil has predicted that computers will achieve human-like intelligence by 2029 and achieve singularity in 2045, which is an AI that cannot be defeated even by adding the collective intelligence of all mankind will appear. After Mr. Son's reversing his retirement, Mr. Son made a $32 billion M&A to buy ARM, British semiconductor design company. And he mentioned that merge was done for the preparation for the future of singularity. SoftBank chairman Masayoshi Son continuously emphasized the meaning of the merging ARM as follows. 1. The Internet of Things, IoT, is the future of the world where microprocessors are connected to all the things. Second, there will be a future where 1 trillion things communicate. 3. In the end, the singularity comes when AI's deep learning wins humans. 4. If the base of the Industrial Revolution was steel, oil, etc., then the resources in the Information Revolution are there. Finally, data cannot be created, analyzed, or trained without the chip. Looking at the IoT-related 2025 forecast, it is predicted that the global IoT connection will grow to 27 billion compared to 6 billion in 2015, and IoT-related revenue will reach $3 trillion. And the amount of data produced by IoT per day will be equivalent to 2 zettabytes. In conclusion, it means that a huge amount of hyperconnectivity will happen. Looking at the IoT platform opportunity in this digital environment, McKinsey Global Institute analyzed the potential economic impact of IoT by 2025 would amount to about 2.7 to 6.2 trillion. Therefore, we wonder who will seize this tremendous opportunity in these future environmental changes. The global spend in IoT-related technology products and services was about $120 billion in 2016, but it is expected to grow at an annual average growth rate of 16%, and the global spend will reach about $253 billion in 2021. Gartner, the world's leading research and advisory company, has been selected digital twin technology annually in the top 10 strategic technology trends for 3 years from 2017 to 2019. Digital twin creates the same thing that exists in the physical world in cyberspace by IoT sensor. The sensor simply collects analog data and stores it as digital data in a one-to-one format. The market is growing rapidly due to the simultaneous development of related technologies such as sensor, internet, artificial intelligence, and 3D printing. And in particular, the declining core technology price, such as sensor, has accelerated the convergence of manufacturing and ICT. As for your reference, the following are the top 10 strategic technology trends for 2019 as nominated by Gartner. As shown in the two photos on the right, when the IoT sensor mounted on the rear thing send analog data using ICT, they are changed to digital data in the virtual space, and it is possible to remotely check the real operation status in real time. Finally, it is a technology that can secure cost and safety by enabling preventive maintenance. The digital twin technology is expected to solve various social problems by expanding the applications to transportation and urban areas, as well as improving manufacturing productivity. At the manufacturing site, it is possible to develop a variety of solutions, such as detecting abnormality signs of equipment with a digital twin in advance, repairing it before failure, analyzing the energy flow of the production process, and eliminating wasteful factors. With the digital twin, 1% increase in fuel efficiency in the aviation and power generation field can save $6 to $8 billion per year, and 1% increase in operation time of energy equipment can save $5 to $7 billion in annual cost. The following is an example of Industrial Internet of Things IIoT application. If damage occurs in any part of the flare tower of the drilling rig, or in the semi-submersible offshore structure itself, or if a problem occurs due to excessive stress in the ship's hull structure, you can easily check them by using digital twin in real time. Identified problems in real time through digital twin can be resolved after checking the repair plan in the virtual space. You can understand what digital twin is and how it works from the following video clip. The third mega trend of the fourth industrial revolution is biology. The core technologies of biology are genetics, synthetic biology, genome editing, and 3D bioprinting, and etc. Innovations at the genetics used to take 10 years and $2.7 billion to do gene sequence. But now it takes only a few hours and costs only about $1,000. In addition, 3D bioprinting enables skin, bone, and tissue production. As mentioned previously, 3D printer can make various human organs and parts of the body at low cost, and it is expected that human heart can be made sooner or later. This video is actually about a woman's skull replacement, whose eyes were blinded due to thickening of the skull, and then she was being fatally affected. However, she was able to save her life by making a plastic skull through 3D scan. You can see the process of replacing the plastic skull made using 3D printer. For reference, woman recovered her vision after skull was replaced.
Voor het eerst is er een complete schedel bij een patiënt vervangen. Onder leiding van hersenchirurg Dr. Bonverwij is er in het UMC Utrecht met behulp van 3D-printing een op maat gemaakte schedel van kunststof geïmplanteerd. Het UMC Utrecht heeft hiermee een wereldprimeur. De schedel van de patiënt groeit naar binnen. Hierdoor komen de hersenen onder extreem hoge druk te staan. Om die druk te verlagen wordt de complete schedel vervangen.
Dus die schedel is van voor op maat gemaakt. En dan gaan we de normale schedel verwijderen. En dan plakken we de hele normale nieuwe kunstschedel, die plakken we erop. En dan heeft ze weer voldoende ruimte. Dit is de 3D gemaakte schedel. Hier zitten ogen voor. Hier is het achterhoofd. Hier het oor. Hier een oor. Dus het is een totale schedel van plastic. Nou, wat we nu gedaan hebben is dat we de twee helften van de schedel weggenomen hebben. En wat je ziet is eigenlijk vanaf de oren tot de kruin dat de hele brein met hersenvliezen open ligt. Nou, dat is nog nooit eerder zo gedaan omdat het een gigantisch oppervlakte is.
De operatie voerde hersenchirurg Dr. Verwij uit samen met kaakchirurg Dr. Mouradin en heeft in totaal 23 uur geduurd. Met de patiënt gaat het goed en deze is weer aan het werk. Deze techniek kunnen we nu toepassen bij patiënten met schedelafwijkingen door ongevallen of andere afwijkingen.
This video clip demonstrates using 3D scan to artificially create a part of our human body.
I was a fine artist. I went to school on an art scholarship, and what really motivated me to get into this field was basically just doing artwork. It's truly an artistic and a technical and an engineering combination of skills and a desire to make something.
Gone for a bicycle ride and I got hit from behind by a pickup truck on a 55-mile-an-hour speed limit highway. Of course, the most visible part of it was that it tore my ear off.
There's all different kinds of ear prostheses, all different sizes and shapes depending on what the person needs. This is the type of ear prosthesis that's attached to a bar clip system for the patient so that it pops on. The patient can wear that with no adhesive. We also have some examples of nasal prosthetics. These just demonstrate when a person loses their part of their nose or their entire nose, they can wear a nasal prosthesis that sometimes is held on by magnets, sometimes held on by adhesives. We've got an example of what we call an orbital prosthesis. And when someone loses their eye and the surrounding tissue, we can design this silicone prosthesis that fits into the orbital cavity and is also held in with adhesive or implants, or sometimes an anatomical fit where the prosthesis fits in like a puzzle piece. A favorite anecdote of mine concerning a little boy who I'd made an ear prosthesis for. This snapped on beautifully with magnets, and he went off to school his first day at school, and he was actually disappointed that he went through the whole day at school and nobody noticed his ear prosthesis. Most people would be absolutely thrilled that nobody would notice their prosthesis.
The 3D scan function is used in various ways and is widely used in the fishery industry. Especially, Norwegian salmon farms are using 3D scanners to identify salmon infected with sea lice by scanning the heads of salmon to identify and prevent the spread of sea lice diseases. This is the last slide of the second session.